This is solid surface countertop material, and it's really beautiful stuff. Though it looks like granite and other types of stone, it's not. It's an acrylic with different colors and aggregates and additives to it that give you all these different effects. These are the samples from 3 different companies that I use. As you can see, there's quite a variety of selections and colors. Now, it's not nearly as durable as granite or other types of stone, but its makeup allows you to create seams in it that are virtually invisible. Scratches and other types of damage to the product can be easily repaired. And it's also required for use in a lot of commercial food service applications because of its antibacterial properties. Now, I wish I could say that it's easy to work with and that you can create beautiful things with just basic shop tools, but that's not really the way it works. This is one of the few trades that I've run into where you have to have a variety of specialized tools to work with it. This video will take you through the steps of creating a vanity top with an integrated sink. I think you'll find it interesting, but you'll definitely learn something about solid surface materials that you didn't know. The first challenge is to deal with a 12-foot piece of countertop material, of which I only need about 48 inches right now. So without a helper, the best thing to do is to cut it up on the trailer. Now, a full sheet of material is 12 foot long by 1/2 inch thick and 30 inches wide. It's going to be quickly apparent that a number of specialized tools are going to be needed to work with solid surface. Now, a CNC machine is not a requirement, but if you build many countertops, it's a big advantage. This CNC machine has a surface area that's 6 foot wide by 13 feet long. That means I can load a full sheet of material on it, and I'm able to cut the whole sheet up without having to manually move it at all if I don't want to. I do my drawings for my cutouts in SketchUp. I then export the SketchUp file and import it into my CNC software. The drawing comes into my software about 10% larger than what the dimensions are supposed to be. I think it's due to the fact that my software is a little outdated, but I can do some calculations and scale the drawing down to the size I need to get accurate cuts. See if I can get a good focus on that. You can see that this particular product has clear chips that are embedded in the material itself. When it's sanded, because you have these transparent pieces that you actually kind of look down into, it's kind of an interesting look. This is a piece that was just shaved off of the edge of the cut that I just made, so it gives you good opportunity to see the translucent or the transparent pieces that are kind of embedded in the material itself. Now, to get to the typical 1.5 inch thickness of a countertop, solid surface edges have to be built up with 2 more pieces of material. Most people don't realize that solid surface countertops normally have 2 seams on every edge that are nearly invisible. This is due to the fact that the adhesive used to join the layers together is cover matched to the background of the material by the manufacturer. Oops! Everything goes well with the CNC machine until it doesn't go well. I forgot that last little corner cut the piece of the edge material completely loose. So here are the build-up pieces in place. Each layer will be glued down one at a time. While it's possible to cut all these countertop pieces with hand tools, it's very labor intensive and tough to get the precision you get with the CNC machine. Prior to the actual glue up, every piece that is going to be joined to another piece needs to be lightly sanded and scuffed up, then cleaned with water and denatured alcohol. This helps ensure a good bond between the pieces. I'm ready to do the first layer of glue up now. I have the clamps laid out here so that I can access them real easily. I actually have my pieces laid out, actually stacked against each other a little bit here so that I can just flip them down into the glue and then start the clamping process real quickly. The adhesive is a 2-part epoxy type acrylic product. It does a fantastic job when mixed correctly, and depending on the temperature, you have about 10 to 15 minutes of working time. Right in the center of the glue spout is where the activator comes out of the cartridge. I always want to make sure that the cartridge is functioning properly by squeezing out a little bit of material onto a piece of cardboard. I can write the time on the cardboard and then have a point of reference for how long it's taking the glue to thoroughly dry. I normally wait about an hour for it to completely cure. Next, a mixing tip is added to the cartridge so that by the time the adhesive comes out the end of the tip, the two parts are thoroughly mixed. This is a warm day, so I'm expecting the adhesive to set up pretty quickly. I'm working about 2 to 3 feet at a time depending on where my pieces align. This should allow me to mix the lines of adhesive together, get the pieces clamped in place, and keep the process moving before the adhesive starts to set up in my cartridge tip. There's a pretty good knack you have to develop for placing the clamps, because what will happen is when you release a clamp, the pressure will cause your pieces to slide around quite a bit because of how fluid the adhesive is. What you're trying to ensure is that you get good glue squeeze out at the seam, and you're hoping to keep the pieces lined up vertically as well as possible. The more clamps you get in place, the easier it becomes to adjust your pieces by releasing the clamps with a little downward pressure or upward pressure that causes the buildup piece to slide slightly forward or backward. I use the little popsicle craft sticks as I go to check the alignment of the pieces. Then I can reposition a few clamps if I need to. As you can see, I get a little bit of a flow going. The whole process for getting this first layer down took about 13 minutes. You really can't allow anything to interfere with what you're doing, so you have to try to preset everything so that all you have to do is work from start to finish. By this point in the process, the first pieces I glued down have started to take initial set, so there's nothing I can do to adjust them now. Okay, it's about 70, probably 78 degrees or so in the shop, I think. And this adhesive is setting up fast, really quick. Got some on my thumb from over here when I first got started, and you can see how it's dry on my thumb. Hope it doesn't take my skin off with it. That's what you run into sometimes with this, so that's why I said initially you want to take it in manageable sections in order to keep from getting into a problem where your glue's already setting up when you're trying to clamp your edge pieces on. After about an hour, I can pull the clamps and set up to follow the same process again to put on the second layer of buildup. I always want to make sure I put the right end of that popsicle stick in my teeth. Now it's back to the CNC machine to clean up the edges. I'm taking off about 1/16 of an inch of material at a time. Once I've gotten to the point that I've cut into the countertop enough to give me a real clean surface to sand, then I can stop. I'm using a 1/4 inch rounded over bit in my router to take off the square edge. Getting the sink ready to install is the same process to sand and clean the areas that are going to be glued in order to make sure there's a good bond. The sink will be clamped in place while the glue dries using an all-thread rod with pieces of wood to hold pressure on the two surfaces. I've added 4 small pieces of solid surface material with a hot glue gun as supports to help hold the sink in place while it is positioned and clamped. It's going to line up on my line right there, get inside my little support pieces. That looks good. Run my clamp up through that. That. And I'm just going to snug this just a little bit to begin with, and then make sure I kind of have equal pressure going everywhere on the clamp itself so it doesn't slide the sink over where I don't want it. Checking everything, I think we're looking pretty good, so I'll go ahead and tighten it down a little bit, then I should start getting more
glue starting to squeeze out on the outside rim here of the sink, and that's a good sign. So you know if that's squeezing out good, then you know you're getting good squeezing out on the inside too, where the ultimate visible joint will be.
I had 2 layers of 1/2 inch MDF to give me the inch thickness I need to match up with the countertop edges. The top edge of the countertop is rounded over to match the bottom edge, and I get ready to do the most nerve-wracking part of this, which is to cut out the sinkhole. It's nerve-wracking because it's pretty much a blind cut that's being made with a big bit. The router bit has a nylon bearing on it that will run against the inside of the sink, so it's not likely that anything can go wrong. But if it does, there would likely be no way to repair the damage to the sink and the countertop and it not show. You can see where the glue squeezed out quite well and gave us a really good bond and clean line on our seam. The final step before installing the top is to sand out the glue lines and any other scratches or imperfections in the top. To get to the final finish on the top, I stepped through various grits of sanding discs and left a 500 grit finish on this top. The big sander holds 4 sanding discs and spins at a very controlled rate, so you get a really consistent finish with it. After making a few cuts on the vanity itself to make room for the sink, all that's left to do is to set the sink, secure it with screws to the vanity, and then install the faucet and the drain. I have a link above to a video on building the vanity, which is a furniture style freestanding vanity, so check that out if you'd like to see how that was done. Thanks so much for watching. Don't forget to subscribe and comment, and take a look at other content on my channel. There's always something going on at Dobbs Workshop.